Erwin Schrödinger, the genius who revolutionized quantum mechanics. The truth about Schrödinger's cat. Early life and education 1887–1910. Erwin Schrödinger was born on August 12, 1887, in Vienna, Austria, to a well-educated and scientifically inclined family. His father, Rudolf Schrödinger, was a botanist and want more videos like this? Don't forget to like and subscribe. And if you really love these videos, leave a comment and suggestions for future videos.
Schrödinger's cat. Sorry, you diverted me. Anyway, in 1935, Erwin Schrödinger, in an attempt to explain the Copenhagen interpretation of quantum physics, he proposed an experiment where a cat is placed in a box with a sealed vial of poison that will break open at a random time. Now, since no one knows when or if the poison has been released, until the box is opened, the cat can be thought of as both alive and dead.
Mathematics and physics. In 1906, Schrödinger entered the University of Vienna, where he studied under Franz Exner and Friedrich Hassenwald, both highly influential physicists. He was particularly inspired by the lectures of Ludwig Boltzmann, whose work on statistical mechanics played a foundational role in Schrödinger's later contributions to quantum theory. By 1910, he had earned his doctorate with a dissertation on fluid mechanics, which demonstrated his early grasp of theoretical physics. Early research in World War I, 1911–1920. After completing his doctorate, Schrödinger worked as an assistant to his mentor, Exner. He focused on experimental physics, though his true passion lay in theoretical pursuits. In 1914, he published papers on atmospheric electricity and dielectric polarization, demonstrating his broad scientific interests. However, his career was disrupted by World War I. Schrödinger was drafted into the Austro-Hungarian army and served as an artillery officer on the Italian front. Though he avoided direct combat, the war deeply impacted his worldview. He spent much of his free time reading philosophy, particularly works by Schopenhauer and Spinoza, which later influenced his interpretations of quantum mechanics. After the war, Schrödinger resumed his academic career, holding positions in Vienna and later at the University of Jena, where he continued his research into atomic and molecular physics. Wave mechanics and the birth of the Schrödinger equation, 1921–1927. In 1921, Schrödinger joined the University of Zurich, where he made his most groundbreaking discoveries. Influenced by Louis de Broglie's hypothesis that particles exhibit wave-like behavior, Schrödinger sought to develop a mathematical framework to describe this duality. In 1925–1926, he formulated what is now known as the Schrödinger equation, a fundamental equation of quantum mechanics that describes how the quantum state of a physical system changes over time. Unlike Werner Heisenberg's matrix mechanics, which was abstract and difficult to visualize, Schrödinger's wave mechanics provided an intuitive. Want more videos like this? Don't forget to like and subscribe. And if you really love these videos, leave a comment and suggestions for future videos. Mathematically equivalent. This realization unified two competing quantum theories and earned Schrödinger international acclaim. In 1933, he was awarded the Nobel Prize in Physics alongside Paul Dirac for their contributions to quantum theory. The Schrödinger's Cat Paradox and Philosophical Struggles, 1935. Despite his success, Schrödinger was dissatisfied with the Copenhagen interpretation of quantum mechanics, championed by Niels Bohr and Heisenberg. He believed that quantum mechanics should describe real physical processes, not just probabilities. To illustrate the paradoxical nature of quantum superposition, he devised the famous Schrödinger's cat thought experiment in 1935. In this hypothetical scenario, a cat is placed in a box with a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, the Geiger counter detects it and releases the poison, killing the cat. If the atom does not decay, the cat remains alive. According to quantum mechanics, until the box is opened, the cat is both dead and alive, existing in a superposition of states. This experiment was not meant to support quantum superposition but rather to challenge it, highlighting the absurdity of applying quantum mechanics to macroscopic objects. However, over time, the paradox became one of the most famous interpretations of quantum mechanics. Later years, Exile and Legacy, 1938–1961. Schrödinger's career took a turbulent turn when the Nazis annexed Austria in 1938. Having openly opposed Nazism, he was forced to flee. He found refuge in England, then in Ireland, where he accepted a position at the newly established Institute for Advanced Studies in Dublin. He remained in Dublin for 17 years, focusing on unifying general relativity and quantum mechanics. One of his lesser-known contributions was his attempt to develop a unified field theory, an ambitious effort to reconcile quantum mechanics with Einstein's general relativity. Though unsuccessful, his ideas influenced later developments in theoretical physics. Another overlooked aspect of Schrödinger's life was his unconventional personal relationships. He maintained multiple romantic affairs and had an open marriage with his wife, Anne-Marie Bertel. Some of his most profound scientific breakthroughs were made while he was romantically involved with other women, leading some historians to speculate on the connection between his emotional states and his scientific creativity. In 1956, Schrödinger returned to Vienna, where he spent his final years. He continued to write on philosophy, metaphysics, and the interpretation of quantum mechanics. He passed away on January 4, 1961, from tuberculosis. A legacy beyond quantum mechanics. Schrödinger's contributions to quantum mechanics remain foundational to modern physics. His equation governs much of quantum chemistry, solid-state physics, and quantum computing. However, his influence extends beyond physics. His philosophical writings continue to inspire debates about the nature of reality, consciousness, and the limits of human knowledge. Unlike many of his contemporaries, Schrödinger saw physics as deeply connected to philosophy and human experience. His thought-provoking ideas, both in science and in philosophy, continue to shape our understanding of the quantum world and our place within it. Schrödinger's cat is a famous thought experiment proposed by Austrian physicist Erwin Schrödinger in 1935 to illustrate the paradox of quantum superposition. The experiment describes a cat placed inside a sealed box with a vial of poison, a Geiger counter, and a small amount of radioactive material. If the radioactive atom decays, the Geiger counter triggers the release of the poison, killing the cat. If the atom does not decay, the cat remains alive. According to quantum mechanics, until the box is opened and observed, the cat is considered to be in a superposition of both alive and dead states simultaneously. This paradox highlights the strange implications of quantum mechanics, particularly how particles exist in multiple states until measured.